Have you ever wished to make your applications completely useless? Probably not. That would be a rather terrible goal. Sometimes it happens by mistake. A common problem with parallel and asynchronous programming is deadlocking. A deadlock, as you might imagine, is a really terrible situation to end up in. As an example, let's say that you have the UI thread. The UI thread is locked because it's waiting for some operation to complete. That operation cannot complete unless it can communicate back to the UI thread. That sounds really odd. It sounds like a really bad idea. Although, ending up in this scenario is easier than it sounds. We need to understand why this problem can occur and how to avoid it. This is an asynchronous method. It's marked with the async keyword. The method returns a reference to the ongoing asynchronous operation. In the best of worlds, we'd simply await this call by using async and await inside the caller method, which in our case is going to be search click. However, for some unknown reason, I really want this to run synchronously. That's why I'm going to force this to block until we have a result. I'm therefore going to call wait on the task that's returned from search for stocks. The task provides a method called wait, which will block the current thread until the data for the task is available. It won't proceed executing the code beneath of it until this asynchronous operation completes. Running this code, in fact, results in a deadlock. This change was rather terrible. It proves the point that it's super easy for us to get a deadlock, especially when calling methods where we've marked them with the async keyword. But how come this introduced a deadlock? Given the fact that we know what happens when we introduce the async and await keywords, can you figure out why this is deadlocking? The reason it's deadlocking is because the state machine and the code inside of it is being executed on the same context. This means the state machine is being executed on the UI thread because the call originates from the UI thread in the search click method. If that's the case, this means that we're blocking the UI thread so it cannot proceed to execute the state machine, which means that the asynchronous operation cannot communicate back to the state machine when it completes. To illustrate this in a slightly different way, have a look at the following scenario. We create this asynchronous operation. The asynchronous operation needs to use the dispatcher or the synchronization context to communicate back with the original context. Now let's add a wait to indicate that we want to lock the thread until all the processing has completed. But this process can never complete because it cannot communicate back to the original context. Hence, we have a deadlock. This is why we should really avoid forcing something to block when calling result or wait on an asynchronous operation that hasn't completed. In the situations where you really want to do this, let me show you a little bit of a hack that you can use to make this work the way you probably expected this to work in the first place. What happens if we move the execution of the state machine to a separate thread? What we're doing now is that we're taking the state machine for search for stocks and we're executing that on a completely different context. Then we block the UI thread until that thread completes. But we're not blocking the particular state machine from executing. So what do you reckon is going to happen now? It didn't block our current context. We didn't get a deadlock. So that's a slight improvement. Although, if search for stock depended on being on the UI thread in its continuation, you will now end up getting exceptions. So you may fix one problem, but introduce another one. The point here that I'm trying to show is how easy it is for you to get a deadlock. And it's mainly because we might forget about the fact that the state machine runs on the original context. And when we are trying to block that original context by using wait or the result property, that will lock our original context. So there's no way for the state machine to be marking this task as completed. The most important thing to remember is to avoid blocking your asynchronous operations, because that kind of makes the asynchronous operations pointless.